An old exam, your exam is going to be pretty similar to this one. So it's really basically the same things you are asking. So we're going to do a few problems. I'm interested in doing problems to see how we are thinking when we are doing it. We can run a large number of problems and we don't know what we're doing. So be careful how we're doing it, how we are thinking doing it. That's the most important thing, not to do too many problems without understanding what we're doing, right? And then about an hour, we're going to have a musical break for about 10 to 15 minutes. One of your classmates will play music and sing, and also two of my older students will come and do the same thing. So we can repeat. Okay, so let's, maybe we should start with which part should we start? You did your practice exam already? You did the practice exam, right? So which part should we stay? 1, 2, or 3? There's 3 parts. You know 3 parts. Multiple choice. Part 3. Okay, part 3. So here's the problem. Can you see it? No. Come on now. Yeah. I don't think it's normal. I think it should be bigger. For some reason, I don't have a full screen. So many times when you come, you find it for total change. I don't know why. Can everybody read it? Okay. So, this it really covers everything we talked about. This, even though it's called a titration, it doesn't matter how you call it. And we do titrations on 10 to B. This is everything we need to solve this problem we already talked about. Okay, so let's see how you will start solving this problem. Huh? What? Why people make a deal about sneezing? This is something to really think about. You know, when you come to college, you need to think about things. You should always ask yourselves, why is this? Why is that? Why people make a deal about sneezing, or they make a deal about some other things? Why? Why do we pay particular attention to certain parts of our bodies and not to others? Why? Why is that? You got to penetrate this surface and go all the way down to find out why. That would be called an educated man to have answers to this question. Which, by the way, you cannot transfer to other people. It will come from within. So let's see. You think it's normal? Why it's so? I think it's small. I think it can be bigger. What do you think? Change, right? We're going to leave it in some way. Just press a button and make it default. Why? Well, there's no default, so you can press it and every time. There's not. Really? So many times you realize it's a problem. I don't know. Okay, so in this case, you took it out, right? So in this case, we want to find out the concentration of the ions. Is better? I think it's much better, no? Okay, so we see that we have what? An acid, right? We have an acid and we have a base. Can you see that? Iodic acid. And then we have potassium hydroxide with the base, strong and strong. And we know strong acid, strong base will give what? Salt and water. Yes? Okay, and in order to find out concentrations of ions of the products or whatever they are there, maybe they are reactions too, we'll see. To find their concentrations, right? We need to consider the reaction, right? And we need to consider the amounts of the reactant species. How are you going to find out how many ions there will be after the reaction is done, unless you write the equation down, right? And unless you write down the amounts that you have for the reactants, to find out what was produced and how much of it, you find the concentration, right? So the first thing we need to do is to start with what we have. Right? So what do we have? We have 50 milliliters of acid solution, and what's the concentration? So if you multiply molarity with volume in liters, you get moles. If you multiply it by milliliters, because it's moles per liter, liter goes away, you will get into instead moles, millimoles. We said that, didn't we? No? Yeah, some people say yes. Okay, so that will be in millimoles. Okay, have you come to lectures? Or you just showed up for the review session? Huh? When you have this MV, if it is, molarity is always moles per liter, times if the volume is in liters, then what you get is moles. Yes? If it's, if the N times V, if the molarity is always moles per liter, and if the volume is milliliters instead of liters, liters and liters goes away, and that milli goes here and becomes millimoles, 1,000 of a mole, right? So remember that, it's very easy many times to do this. You do many things faster, especially for this type of problems, titration. So we have 50 milliliters times this concentration. We have, actually when we react this aqueous solution of acid, we have how many millimoles of hydrogen iodide? 5 millimoles. Yes? And then we react this with the base. So how much is the base? 30 milliliters times the concentration on 2 molarity, and that will give us 60. This is 50 actually, right? But nobody says anything. 60 millimoles potassium hydroxide. So we found out the amounts in millimoles, doesn't matter, moles and millimoles, of each reactant, right? This is what we start with, and we want to find out concentrations of ions, so we're going to have to use the equation, the chemical equation, to see what's happening. When you know the amounts of both reactants, immediately you have a problem of, come on, limiting reactant, right? Whenever you have the amounts of both reactants, immediately you know that you face, most likely, you can see what happened. Okay. So the first thing we need to do is when we have stoichiometric, when we have problems on stoichiometry that involve chemical equations, we write the chemical equation, and it's a very good custom to do it the way we're going to do it today. I think we've done it in class 2. What you do is, after you write the chemical equation, you know that this is aqueous, right? Aqueous, liquid. You can put under each substance the number of moles, grams, whatever. Okay? So I will say initially, that means before reaction, right? Before any reaction is taking place, How much of this we have? 50. 50 millimoles. How much of this we have? 60 millimoles. And from this one we have 0 millimoles. Why? Because no reaction is taking place. When we say initially, we mean reactants, no reaction is taking place here. And then we can put here change. So in this line we're going to do the change. From this one, it's really easy problem. You can see from the reaction, the equation, that 1 reacts with 1. It's 1 to 1 mole, 4 millimole. Ratio of moles will be ratio of millimoles, yes? Yes? 1 to 1. So it's very easy to see that the 50 will require 50. And we have excess, right? So what will happen? The 50 will react, so that's going to be minus 50. If they react 1 to 1, 50 require 50. So all of the 50 will go away. And if 50 of these react, how many are going okay, minus 50 from here. And how many of these will be produced? 1 to 1 to 1. Minus 50 from here. Minus 50 from there. 1 to 1. And it will be produced. Plus 50 millimoles of this. Yes? Okay, and at the end, I will say finally. We can say finally. Or you can say after the reaction. You can put the word after. Finally is going to be 0 here. How many here? 10. And here is going to be 50. Yes? Millimoles. Millimoles. So, after the reaction, what really we have is this. Don't be confused. These are what we're going to have after reaction. And if we have this after reaction, 10 millimoles of this and 50 millimoles of that, we're going to concentrate on these numbers to find out the concentration of the ions. Yes? Okay. So we take each one of them. Okay? We take very easy problem if you know how to do it. If you think logically. Okay? So that's what we're trying to find out, how to think logically, step by step. Everything we do it for a reason. Searching, not just memorizing the problem. Okay? Has nothing to do with the problem. We take now these two, right? So we take 10 millimoles of potassium hydroxide, and we want ions concentration, so we have to break it into ions. Otherwise, how are we going to find the ions? So this actually is like that, isn't it? Each formula unit has 2 ions, right? And so when we say 10 millimoles of this, one formula unit has one of these ions and one of the other ion. The ratio of particles is the ratio of moles, or ratio of millimoles, yes? The ratio of particles is ratio of moles and ratio of millimoles. So, if I have one of this, it has one of this and one of that, 1 mole of this, we'll have 1 mole of this and 1 of that, and 1 millimole of this, we'll have 1 millimole of that and 1 millimole of that, and 10 millimoles of this will have 10 millimoles of what? This, and 10 millimoles of that. Yes? And then you do the same thing for another one. 50 millimoles of potassium iodide. That will give you, again with the same reasoning, 50 millimoles of potassium plus and 50 millimoles iodide ions. Okay, great. So instead of this now we have this. So actually we need to find out for 3 ions, potassium, hydroxide and iodide. But these two, we have to sum them up, and that will give you 60. Okay, so now basically you concentrate on this here, this one here, and this one here. These are the 3. We know we have the number of millimoles, but we want concentration, molarity, moles per liter, right? So if you divide the moles per liter, per milliliter, whatever, you can get the molarity. Yes? We'll see now what we're going to do. So the concentration of, let's say, potassium plus, first one, when we put brackets, we usually put brackets, we mean we have molarity. That's what means molarity. Okay, so if I have molarity is moles per liter, I better put something on the numerator that will have the word mole, right? What do I have? Well, the only thing I have is what? 60 millimoles of potassium plus. Whatever I have, I put down. I don't have anything else. I don't have moles. Molarity is moles, but I don't have any moles, millimoles. Okay, if I want moles per liter molarity, then I better put here what? Milliliters, right? So, what do I have from the problem? Let's see, 50 milliliters and 30 milliliters. So, I'm going to divide with what volume? Total volume, right? Because we mixed them. So, this number of millimoles that they were produced, they are now in the whole solution. So, this is the sum of the two volumes of the two solutions. So, that's going to be, actually, this problem is tricky too, right? Because it tells you, you mix the solutions and you add, and 100. The ones that I didn't see that, they lost point because this takes work. So you don't do the whole problem, but you miss some points you don't see it. So you actually mix the solutions and on top of that you put 100 milliliters of water. So the total volume actually that these millimoles are is 50, right? Plus 30, plus 100, right? All of this is the volume of total. And mils goes away, and we're going to have moles per liter, which is molarity. And if you do the calculations, you find out that it's this thing here. Now you can do the rest for yourselves. Isn't it true? Or you want me to do it? Just take the number of millimoles of each, and divide it by the total volume, same number, same three things together, and you find out the answers, which should be, for the hydroxide, should be 0.0556 m, and for the iodide, should be 0.278 molarity. Okay, the same way. Did you see how we did it? Don't waste your time in college by memorizing things. If you feel that you have a driving force to memorize because you don't like what you're studying, then you need to come to the gardens to talk about it, why it happened, how we're going to together to heal that, because it's kind of a disease. At the end, it's going to bring a lot of pain. If you put band-aids for 4 years, at the end it's going to be a big wound. It's going to bleed. If you don't want to understand now what these things mean that your teacher is talking about, you will, but after a lot of pain. So you don't want to go through pain. You're smart. You want to be happy. You don't want to go through pain. As much as little. Isn't true? Everybody is looking for happiness. Okay, let's go to the next one. Any questions for this? Any questions? Okay. Okay, let's see the other one now. Actually, the other one was also is a problem that some students come and ask how to solve it, and I realized that this problem, if you don't approach it the way we're talking about, thinking about first how we're going to think, it can get really confusing, or you can just spend a lot of hours and you cannot do it. You have to think very logically. You focus, okay? You focus on what you're looking for. You remember what they gave you to use, and then you do it. Now you can do it, huh? There. I made up this problem. I don't think there is many other texts, and the reason I did it is because when I was a student, I was always wondering, these two percentages, they are similar or very different. But if you do it, you find out that the numbers are very similar. But they are not the same thing. One is atom percent, and the other one mass percent. Two different things. The numbers might be very similar, but it's two different things. So, what is each? you must know to be able to solve the problem, right? Atom percent is what? In 100 atoms of the element, how many atoms this type of isotope, and how many atoms of the element of this type of isotope? Yes? And mass percent is in 100 grams of the atoms, right? How many grams of this isotope, and how many grams of that isotope, right? Okay. So there are very different ways of expressing the concentration. Okay. So, but the beauty of this problem is, as I said, if you do not approach it logically, you can work for a long time, get really tired, and not be able to finally do it. So you have to focus on what you want to find. You have to know what you're looking for. You know how many students come to office for office hours? Quite a few students come, and they are telling me what they're trying to do. And then I ask them, what are you looking for? Many times they do not know what they're looking for. They can answer the question, what are you looking for to find? They have not looked into the problem to know exactly what the problem is asking. Then I go on and I say, okay, the problem is asking for this. And you told me all this way how you're trying to do it. But when the problem is asking about X, what is X? If it asks about blah, 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 what is blah, blah, blah? What's the definition of it? What is it? And they do not know. So how can you solve a problem when you do not know what you're looking for and you don't know how it looks like? If I want to find something it is in this room, if I come in the room and I'm looking for it and I don't know what it is and how it looks like, I will never be able to find it. So you guys have to really think logically. The ones who graduate from college and has managed to focus and to learn how to critically think, that's the one who will be college educated. Not the ones who has memorized things and have big grades. The grades, at the end, maybe they will give you a job, but eventually, that's not the thing that will make you happy. Unless you learn how to to focus, to control your mind, to focus, to have good decisions, you will never be able to be successful, truly successful, which takes to be happy too, not just to have a job. Is that true?
Yeah.
Very true. Okay, you got it down? Huh? So let's see how we're going to think about it logically, right? To solve it. All right. Now, the first thing that I want to do is I want to write down what we are looking for. Okay? So write down what you're looking for. What are we looking for? It says calculate its mass percent composition. If chlorine is found in nearly two isotopes, its atomic percent composition is between this much and this much. Calculate its mass percent composition. Okay, now, you see, there are some things that before you start writing and doing things, it's very good to think about. Because that saves you a lot. In fact, you can solve the problem, otherwise you might not be able to solve it. When it's giving you percent composition, whatever they are, who cares? If it's two things and gives you one, you know the other. One thing, that's a fact. Second, it's asking for a different composition, right? So, again, I don't need to calculate both immediately. If I find one, I know the second, right? So you need to concentrate on only one. Is that true? You don't have to deal with two things, 35 and 37, two isotopes, just one. If you find one, then you find the other one. Okay, so you have to make up your mind which one you want to work with. Why would you choose 35? It doesn't really matter, because you see it gives you atomic percent composition for both, and it gives you the atomic mass for both. So it doesn't matter. You choose one of the two. It doesn't matter what you choose, the result will be the same. Okay? So let's choose, as she said, 35. Doesn't matter. And if it's not, that's when we will choose, right? It's asking for what? The mass percent composition. That means, now you have to translate that. That means that you have to find what? you need to find out, so he's asking what is the mass percent composition. That means how many grams of chlorine 35, because you chose that isotope, you could choose the other one, doesn't matter what you said, per what? 100 grams of what? What am I going to put here? I don't know any books that they talk about this, but it's really important to recognize it, and it's voila, it really becomes so much easier to do this kind of stuff here. What I'm going to do here, I'm going to put Cl atoms, Cl2 molecules, or I will use the word chlorine. That's what I'm going to do. It really doesn't matter. And so because it doesn't matter, I just say this to make things easy. It doesn't matter. If I put Cl or Cl2, it doesn't matter. As long as I talk about grams or kilograms or tons. If I talk about moles, I better put what kind of, if you have read the reader, this stuff there, really good stuff, you already know. You don't find in other books, do you? No, you don't. Unless you didn't read it yet. And you really will never have these difficulties again. So it doesn't matter what I put, okay? So this is what we want to find out. Here it is. If I find out how many grams of chlorine 35 I have per 100 grams of chlorine, I'm done. Okay. So now I'm going to see what the problem is giving me. If I want to find something about 35, I better choose from these numbers that which talks about 35. I'm not going to choose 37, waste my time. Yes? Makes sense? Alright, and how many things do you know about 35? 2. Well, let's put them down. Okay, so the first thing is telling us that we have an atom percent composition of chlorine 35, and it looks like this: 75, period, 75.77. Atomic percent composition, what does that mean? We have so many what? Chlorine 35 isotopes, they're atoms, right? Per what? Per 100 of what? Okay, atoms. Atoms of chlorine. What kind of chlorine? It doesn't matter. 100 chlorines, whatever they are. Statistically, if you have all these atoms all like this, it's just whatever you get 100 will be the same ratio between the two, right? So I'm going to say 100 of chlorine. It's a mixture of the two, right? The same ratio that the mixture is. Okay, and then what else does it give me? It gives me also another ratio from the other information, right? And that is from the atomic mass of chlorine 35, right? So this one comes from what? The atomic percent composition. And the other one will come from atomic mass, okay? And it tells us that it is blah blah. Where is it? AMU. Okay, so it's 34.96, 88, 52. You have to reuse a lot of significant figures because they are very close. If you don't do that, you might not be able to solve it. That's why the problem says to do it. Okay, so we have so many AMUs per what? Molar atomic mass, isotopic mass, right? There's so many AMUs per what? Per one atom. What atom? What kind of chlorine? You see, if you don't put these things down clearly, you will never make the result here. You've got to be very accurate when you put down. Always when you write one number, will have two things, the unit and what it is. Always three things. 3. You miss this or you mix them up, forget it. Especially for problems like this, it's a little bit challenging. Okay? So, this one we said comes from where? That comes from the atomic mass. That comes from the atomic mass of chlorine 35. Okay? So this is what you want, this is what you have. Okay? Can you see? Yes. Okay.
So now, let's see logically how we're going to think. Really easy. If you focus to what you want and what you have, it's a piece of cake. Okay? So, I want this. Therefore, if I want this, I want to start with something that has chlorine, grams of chlorine 35. I want to start with something, yes? If I want that ratio, I have to start doing my train here. And if I want grams of chlorine 35, I have to have that. Otherwise, how it's going to appear? And I'm looking here, and I don't see it. Do you? Do you see anywhere chlorine 35? I don't see grams of chlorine 35. I don't see it. I see chlorine 35 right there. Yes? Well, maybe I can do something about it. So, from these two that I have, this really does not help me because it has a chlorine 35 down. I want it up. So if I want it up, I better choose this. Yes? Now, this one is atoms per atoms. Yes? And I don't really want atoms, I want grams. How am I going to go from one to the other? How? What concept do you use? How do you go from quantity to amount or amount to quantity? Come on. No. One word. Moles. Moles. From particles to quantity grams, we go through moles. Can you see? Every time I make a step, I have an answer why I do it. I want 35 on the top. From these two, I choose this. Okay, I choose this. And that's atoms per atoms. We said that we want grams. Okay, I have particles. To go to grams, I will go through moles. Okay, so you know any relationship of this ratio with moles, to go from atoms, particles to moles, and then I can go to grams? Do you see anything from here? What is the ratio of particles also? Ratio of? Come on. Ratio of particles is also ratio of?
Moles.
Moles. Why? Because each mole is always Avogadro's number of particles. Yes? You don't need to prove it. The ratio of particles, whatever they are, is also a ratio of moles, or ratio of millimoles. You got to write it down. And if you do not understand why, then you ask a TA, you somehow answer that question to yourself, and then that's the end of the story. If you don't do it tonight or tomorrow, and you leave it behind, and you go to third year, and you take I don't know what, and you still don't understand why in the ratio of particles, the ratio of moles, that's not a good idea, is it? No. Okay? So then I'm going to write this as 77 what? Chlorine moles of chlorine 35, yes? Divided by 100 of what? Moles of what? Atoms of chlorine. That's why I put it in brackets, means atoms, chlorine, right? As long as you use the word mole, you have to specifically say what kind of particles. So chlorine 35 atoms, chlorine atoms in general. Doesn't matter what they are. Okay, so I want 35, I start with this, I want grams. How I'm going to go to grams from particles through moles? So it seems like to me that I might have to, most likely to use this one. Okay, let's go to the other one now. How about this one? Already I have these moles, that will give me from grams to, from atoms to number of particles to moles, and I want to go to grams. Here, grams, can you see grams there? Maybe this one will give me grams. Wait a minute, I don't see any grams here. You see any grams here? Maybe there are. Maybe I can write something similar in grams. How can I write this one in grams? Is there anybody who knows? Do you remember we said that always the ratio of whatever it is in AMU per particle is also a ratio of grams per mole. You remember? Again, if you don't understand why, go and find out why, prove it, and then you will never forget it. Very easy to prove it. Okay, so if you have something in AMU divided by the atom, sorry, for the particles, right? So you have so many AMUs for so many particles. That ratio is also grams per mole. You use that one, you use your periodic table, isn't it? When you say phosphorus is 3.97, that's one atom of phosphorus, AMU. If you have 1 mole of 3.97, right? Grams will be 1 mole for phosphorus. Yes? Yes. That's right. So this one, I can write it then 34.96, 88, 52 grams, right? Grams of what? I forgot to put here, and nobody said anything, chlorine 35. It has to be there. Chlorine 35. We know what it is. Otherwise, we're in trouble. And this is per 1 mole of chlorine 35. The problem is really solved now. Because we want this, right? And we have these two ratios which, by manipulating them, we're going to go into where we want to go very easily. So now, I'm going to go into this. This is what I want. So I want on the top grams of chlorine 35. Do you see anywhere grams of chlorine 35? There it is. So I'm going to use this ratio then. If I want that, I better use it. So 34.96, 88, 52 grams of chlorine 35. I already set it up in such a way to get what I want. Divided by 1 mole of chlorine 35. Good. Okay, now, what I'm going to do to go to where I want. I put as many as I want. Don't say why you put 2. I can imagine as many as I want. Okay, so basically what you see here is you have this right there already, and you want grams of chlorine on the bottom, right? Do you see any grams of chlorine on the bottom? No, really. We used already this. We don't have grams of chlorine here. So, we can think about it later. We see 1 mole of chlorine 35 there, right? And I don't want it, because I want grams of chlorine, so this has to go away. So how is it going to go away unless I put moles of chlorine 35 there, and then it will go away, yes? So that tells me now to find out something here that has chlorine 35 on the top, moles. Do you see anything like that? There it is. See it? So I'm going to put 75.77 moles of chlorine 35 per 100 moles of chlorine atoms. Okay? We're almost there. We have this, we want this, I don't want this, but I want that. So if that's the case, if I don't want this, then I better put it here. Mole of chlorine 35, and if I want this, I better put it down here, grams of chlorine, and see if I can find the ratio, because then I'm done. This goes away with this, and I have what I wanted. I have the unit I want. So the question now here is, do I have something, a ratio that I know of between grams of chlorine and moles of chlorine 35? Actually, it's let's see. Moles, no, this is wrong. Just a minute. It's, this is correct, right? And we want to get the moles of chlorine out, right? We want this, so it's moles of chlorine, like this. There you go. Okay, so when we get this off, right, go away. So we're looking for moles of chlorine atoms per grams of chlorine. Well, what's the relationship? 1 mole of chlorine atoms, how many grams? There you go, periodic table, right? 1 mole of chlorine atoms is going to be the same number as 1 atom of chlorine in AMU. Same number. So 1 mole of chlorine atom is going to be how much? 35.44 grams of chlorine. That's it, we are done already. The units are the one we want, all the others go away. So you just put the numbers there. You see, anyone who could say, you solved this problem for us, but you didn't tell us how. Why did you think that way? He would be lying. For every step we move from one place to the other, your teacher explained to you why we did it. And this is the way you should solve problems. Whenever you solve problems, this is the way you solve them. You answer to yourself why you went from here to there. Why? Reasoning. Why did you do that? This is not the way most students do solve the problems. They don't solve them that way. And that's why they have always doing the same thing and again, but they never really learn. Do you agree with that, or you don't agree? Oh, there you are. What time is it? Almost there. Could you wait a little bit? A minute? Okay. So you have any questions with this? After the calculation, you find out that it is so what you do here now, you're smart. You 1%, right? You 1%? So what you do is, you can see here, this is your units, and you 1% per 100 grams. So what you do is, you don't touch this. That's 100, right? Don't touch it. So just the calculations of all the other ones, whatever happens, that will be a number where? Right there. And that will be percent. The number you can calculate by doing all this, and you don't touch that 100, will be the percent, isn't it? Because that will be how much per 100 grams. Yes? So you already have that. Did you understand what I'm saying? Well, you want me to write it again? Like this, times all the rest, blah, 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 blah. That will be a number right there per 100. The unit's the same, so that will be the percent. You see? So you do all these calculations, you don't touch the 100, that number will be the percent. And you will find out that it is 74.74% chlorine, 35 mass percent, right? Mass percent. And the rest of the 100 will be the other one. If you don't do it systematically, yes, you might try it for 2-3 hours and you will not get the answer from the reader. You will say maybe the problem is wrong. But you really have to do it systematically. Did you see that? Every problem is done so slowly and step by step thinking. It's the same thing.